Here we go, class. So today we are starting 2.1a, notes composition of functions, okay? Composition of functions is going to be very doable, very easy, but you have to pay attention, okay? If you do not pay attention, you will get lost in the sauce, and I don't know how to help you from there, okay? All right, but again, it is very easy. If you can do today's do now, then you can do this. Got it?
Yeah.
All right. So let's start off by defining what a composition is, okay? So what is a composition? Basically, a composition is written as G, this little O, this little circle, that means composed. So this little guy right here means composed, okay? G composed of F is how this is read. That's what that open circle means. G composed of F. It's written for you. So when you have here, what happens is you're putting a function inside of a function. So when it says G composed of F of X, that means I'm taking the whole function F of X and I'm plugging it into G. So what used to be X now becomes whatever F of X is, okay? The domain of them, the domain of G composed of F is going to be mixed of the values from F of X. So your domain is merging. Why? Because you're merging two functions together, okay? And then, so if one domain has restrictions, then the other may have restrictions. Okay, it's just like when you're merging two families. When you have a blended family, if there's something that this blended family doesn't do, the new blended family may not do as well. Does that make sense? Everything is going to try to be the same, but some things are going to change. When you are evaluating, you're going to evaluate the inside first. So step one is to find F of X. Then step two is to plug that into G. And then vice versa, okay? They are not commutative, meaning that if I did F composed of G of X, I'm going to get the same thing as G composed of F of X. They are not commutative. They're their own identities, okay? They're their own functions. The results are going to be different every time. Or they may be equal depending on the graph that's being created. Okay, so the best way to do this is just to dive in. We're going to start off with tables. Tables is probably the easiest thing to look and see what I mean by working from the inside to the outside to find your final output, okay? So on your table, you should have this. And our first example that we're going to do together, it says F composed of G of 3. So again, it says F composed of G of 3. You're going to do the inside first. So on the table, I'm going to go to 3, and then I'm going to look at table G. So I go to X equals 3, and I'm going to look at table G, and what do I get? 2. So I'm now going to replace this with a 2.
Wait.
Be nice. Okay. Thank you for helping him. All right. What are your questions? Overall, we're okay? Okay. Then now you substitute in what you got. And what did we get? 2. So now we're going to do F of 2. So I'm going to go to X equals 2 and look at F. Go to X equals 2 and go to F. And what do I get? So my final answer is 8.
Oh, so it's just like you just look it down the chart. All right.
Okay. So then we're going to do it again. So we have G
I get it now.
composed of F of 3. So remember how we said it's not commutative? Meaning that I'm going to possibly get a different answer because just because I did it one way doesn't mean the other way is going to give me the same answer. So again, we start on the inside. What's my inside? 3. And I'm going to go to which table? F. So I'm going to go to X equals 3 and go to F of X, and I get what? 3. So now I'm going to substitute this in with a 3. Now I'm going to go to 3, but this time I'm going to table G. So I go to X equals 3, go to table G, and what do I get as my final output? I get 2.
Oh, just 2?
Just 2. My output is 2. No, you're evaluating. You're not getting rid of, you're just evaluating. I'm using the number, so no longer am I needing the whole thing.
So we got the answer. No, we didn't.
No, we didn't. We got 8 and 2.
Yeah, I don't know why I thought that. I wrote my 2, I went 8 here.
I don't know. All right, how do we feel? Okay, here's your turn. I'm not gonna help you. You can help each other, but I want you to try.
Oh, yeah, this is hard again.
Ow. Check with your table.
I got it. I don't know.
60 more seconds.
More than even on the paper. Yes, it
It's a lot of fun. That's an egg.
It's an X, that's just telling us we wrote which.
Oh, well, look, it's so high. Look.
At least babies come up in. Wait, which one am I starting off with? I'm having the same.
Start off with the X. You always start with X.
Oh, and that is an X.
I'm gonna go to the X first.
You do the other one. I'm back. Why is it like-
Yeah, it's good, 10,000.
All right, guys. Let's check and see how you did. All right, so on the first one, you had F composed of G at 1, right? So you're gonna go to 1. So you're gonna go to X equals 1. But table first you're going to is G. And what did you get? 3. So now you have F of 3. So I'm gonna go to X equals 3. And this time I'm looking at table F. And what did we get? 3. Good job. Okay. Now let's do G composed of F of 4. Inside first, 4. So I'm going to go to X equals 4, but what table am I going to? F. So table equals 4 and I get 1. G of 1 leads me to 3.
Oh, okay, so I did it right.
All right, how do we feel?
Just barely easy.
Fairly easy? Still good? All right, so after tables comes graphs. Okay. Do you think it's going to go anything different?
No.
No, it is not. Okay. With the graph, usually the graphs would be graphed on the same coordinate plane. I wanted to make it very easier, so I separated the graph. But normally they would be graphed on the same coordinate plane. They would overlap. Okay. But for us practicing, I kept them separate. Okay. All right. So look at our example. We have F composed of G at 1. So we're going to graph G and we're starting at X equals 1. Do we see that? So I'm starting at graph G and I'm going to X equals 1. You start with the inside. Inside, you work inside to out. That made no sense. We're gonna keep going.
Wait, so you'll go up to 3? You'll go up to 3?
So we go up to 3.
Okay.
So then what do we get here? What is the output at 1? The output is 3. So now this is going to become F of 3.
Okay, so for the F, down.
Guys, let me go. All right, so here, all right, we're going to x equals 3, and now we're on graph F. So I go to x equals 3, follow it to the function,
6.
and where am I at?
6.
6. So my final output is
6.
6. That is it. That's the difference between a graph and a table.
Oh.
Okay.
I was thinking.
All right, y'all are gonna do the next 2 examples quietly on your own, then check with your peers. Okay. Yes, there is. All right, here you go.
Wait, one?
Will the first one be a negative?
Oh, I get it now.
Will the first one be a negative? Yeah, because that's what I'm thinking.
D's on the right. Not actually.
Okay.
Oh, gosh, me too.
Negative 4 stays negative 4, right? The second one, negative 4 stays negative 4, because it's only right here. You start with what's in the parentheses. Yeah, you start with in the parentheses, like that's not good. Right. I got one for it. What means 0? How do you get negative 4?
Okay, so the middle one is your X.
Okay, I was so confused.
All right, ready? Okay, so here we go. We have on this, our first one, we have F composed of G at -6. So I'm starting on the inside. So I'm gonna go to graph G and go to x equals -6. This is graph G. I'm gonna go to x equals -6. And what is its output? 3. So that's gonna give me F of 3. So now I'm gonna go to graph F and go to x equals 3. Graph F, going to x equals 3. And what is its output? -2. So my final answer is -2. Yeah? Okay, next. So now we're gonna do, this one says F, G composed of F of -4. So inside, I'm gonna start on which graph? F. So I go to graph F, and I'm gonna go to x equals -4. And what is that? 0. So now we're looking for G of 0. So we're going to graph G, going to 0, and what do we get? -3.
This is easy.
Okay, how do we feel about part 1?
Easy.
Good? Questions, comments, or concerns? A little, are you still confused?
A little bit.
Okay, where are you confused at?
So I'm just working.
Right here.
I'm just working inside. So whenever it says GX and then FX, it's just.
Those are the name of the function. So those are, remember, every graph has a name. So this graph's name is G, this graph's name is F. And so you're gonna go to F first and find its output. Yes. You focus on the inside first. I'm going to F first at x equals -3. I go to F and go to x equals -4. And what do we get? 0. So now I'm replacing that with 0 because its output is 0. So now I have G of 0. And now I'm going to go to G, go to x equals 0, and my output is -3. Okay. Like a chain reaction.
Can you do it again?
So starting inside.
Negative. It's like.
Yeah, it stays. Output in three. Now we have F for three. We just found out. Now we're gonna go to F. F, go to X equals 3.
I don't know.
So it is. Okay, you're welcome. Part 2. Okay. Let me stop this